All right, we're looking at worksheet A16 today. So we're jumping into something new and we're working on square roots, and this will all eventually come back around with quadratics because when something is squared, the x squared makes it a quadratic. So we are getting into our square roots, and it says, let's recall some things we learned about square roots. This is not the first time you guys have seen them. If a squared equals b, then a is a square root of b. So what's that mean to us? Because I know that's a little bit abstract when you read something like that. If 5 squared equals 25, then that means 5 is a square root of 25. Yeah, I mean, that's what it's saying. If a squared is b, so if I can square 5 and get 25, then 5 is a square root of 25. A square root is a number times itself that would give you that product. Now, you guys made a square list or square root list yesterday. So on your list, mine looks a little different than yours probably, but on my list, 2 squared is 4, 3 squared is 9, 4 squared is 16. You should be very comfortable with up to 12 squared is 144. Obviously, there's infinite square numbers, but you are really just counting to see. Now, if there's something beyond your list and you want to know if it's a square number, like 256 might not be something you realize. So you would just take your calculator and you would take the square root of 256. If you get an integer out, a nice integer like 16 with no decimals, then 256 is a perfect square. But if I take the square root of 250, I get this ongoing decimal. And this is irrational, okay? It doesn't look like it fills up my screen, but it would keep going forever. This is not a perfect square because it's irrational. And so the idea in this lesson is to not get the decimal answer, but get the exact answer. And we're going to break this 250 up with whatever perfect square we can take out. So that's the big idea. Now, the radical symbol looks like this. And when you don't have a little number, this is called your index. If there's no number there, it's given that it's a square root. But truly, there is a 2 given there, but it's such a common root we don't write it. The expression under the radical symbol is called a radicand. So if I have the square root of 25, 25 is the radicand. All right? Radicand? Yep. That's why math is radical. All right. Every positive number will have 2 square roots. So when I say, what can I square to get 16? Well, I can square a positive 4 because that's 4 times 4. Or I can square a negative 4 because it's negative 4 times negative 4. Those 2 negatives cancel. I cannot stress enough when we use the calculator that you need to put this in parentheses. Okay, so the expression, this root of 16 means square root of 16. Square root, and you know that, of 16. Or the positive square root of 16. So whenever we give this answer, a lot of times we will just say 4. That's the positive root of 16, or the principal root. Now, the expression negative square root of 16 is basically meaning the opposite. The opposite, oh no, of the square root of 16. So when we talk about our square roots, we're only going to talk about the positive root. So the square root of 16, well, we're just saying it's 4. But if I asked you what squared gives me 16, that's when we have a positive or a negative. Okay, now, the expression negative square root of 16 is the opposite. Whenever you take a square root, you're going to get a positive outcome. But if we take the opposite, we would get negative 4. All right, now here comes the big part of the lesson. And again, you've already seen this, but we're going to do it like you haven't seen it before. For all numbers where a and b are greater than or equal to 0, so basically for all positive numbers, okay, we have to use positive numbers, the square root of a times b equals the square root of a times the square root of b. All right, so we have a goal here. Our goal is to keep exact answers. You got a lot to say back there. Our goal is to keep exact answers. So no decimals. I say that, and then someone's going to come to me with their worksheet, and I'm going to give it right back. No decimals. We're not putting it in the calculator and just getting a decimal. So we want to find the biggest perfect square to break it down. Find biggest perfect square. I'm going to add to that. We're finding the biggest perfect square factor. All right, so take a second, get that written down. Well, let's take a look-see.
Wow, that was great.
All right, now look at the square root of 81. I'm going to look at my little perfect square list, and 81 is on it. What's the square root of 81? It's 9. Okay, so I'm done. That is an exact answer. There was no decimal, no rounding. Guys, if you remember your times table, the perfect squares are on the diagonal. The 1 times 1, the 2 times 2. Remember that diagonal in your times table when you were little? Anybody? No?
Yes, I do.
Oh, my. All right, square root of 20. If I type, well, first of all, it's not on my list. Do we agree? Not on my list. If I type in the square root of 20 in my calculator, I am going to get a decimal. That means this is an irrational number, and I cannot have this decimal. The minute I write even this whole decimal down, I have rounded it. So I need to find the biggest perfect square that goes into 20. You want the biggest. It is 4. Perfect square. That's your goal. Now, how do we know it's the biggest? There's a couple ways to check that. Let me get in here a little tighter. All right. So there is that rule that I gave you. The square root of a times b equals the square root of a times the square root of b. Basically, if I have multiplication, I can break them up and take the square root of the individual factors. So I would normally skip this step, but here's the idea. 4 is on my list, and it goes into 20. Now, how do I know I got the biggest perfect square? Well, 9 does not divide into 20, 16 doesn't divide into 20 evenly, and 25 is too big. So I want a perfect square that divides into it, a factor of it. Now, see how I have this 4 times 5? I'm going to use my rule and rewrite it as the square root of 4 times the square root of 5. And I like to put my perfect square first. I like to put my perfect square first because what is the square root of 4? Come on, I know you can do it.
16.
No, the square root, not 4 squared. Square root of 4 is 2. So I'd write this as 2 times the square root of 5. The square root of 5 is stuck, it doesn't break down, and there's no perfect square factor of it. So my answer is simply 2 square root 5. Now, I wouldn't show all this work. I wouldn't show this step, and I wouldn't show this step. But I want to make it clear that I'm multiplying these numbers to get 20, and due to this rule, I can break them down. And it's 4 square root of 4 times it, it's 2 times it. And then you read this as 2 square roots of 5, or 2 times the square root of 5. 2 square roots of 5 is understood. All right, let's go over here to 18. Square root of 18. Is 18 a perfect square? Is it on my list? No. Okay. Is there a number in 18 that I can break down that's a perfect square? 9. Now listen, I always say you need the biggest perfect square, and I had a kid go, well, then why do you always start with 1 and 4? If you need the biggest perfect square, why don't you start high? Well, 16 doesn't go in, but 9 does, and that's fine too. So 9 times what? 2. All right, so do you see that I'm already skipping this step? I'm going right to this. It is truly 9 times 2 is 18. And then I'm going to break that multiplication up. What is the square root of 9? Okay, so it's 3 square roots of 2, or 3 times the square root of 2. Now, this is what most kids look at this and say, how is this simpler than the square root of 18? And the idea, it's like reducing a fraction, right? You take out the common factor. We are taking out a perfect square. So what's left underneath the square root is smaller. Now do me a favor. Type in your calculator the square root of 18. All right, now remember that decimal, 4.24, and it goes on. Now type in 3 square root of 2. Do you see I get that same decimal? So that's how I know I didn't screw it up. And how do I know I got the biggest perfect square? That 2 doesn't break down any further. All right, let's go down to number 5 while we're right here. Is 75 a perfect square? Nope. Okay, are there any perfect squares that divide into 75? When I say divide into 75, I mean that there's no remainder, no decimal. 25 does. So here's the deal. These are all perfect squares. A number times itself, 5 times 5, 25 is a perfect square. That's why I'm focusing on these lists, because any of these numbers I can take the square root of. I can't take the square root of anything between 16 and 25, because that's between 5 and 6. So if you cut this number in half, it's like 35.5, right? No. What is it? It's 37.5, sorry. I would look for any number smaller than that. So 36 isn't going to go into it. 25 does. That's my biggest perfect square. 25 times what? Times 3. What is the square root of 25? 5. Keep the square root of 3. So basically we divided this up and took out a chunk that I could take the square root of and break it out of the root sign. All right, now go back over to the right. Number 4. Number is 72. Not on my list. We agree. What goes into 72 that is a perfect square? And I want the biggest perfect square. Yeah, 36 is it. But is there anything else that goes into it? 9 goes into it. Did you catch that 9 goes into 72? Guess what else goes into 72? 4. Okay, so there's 2 ways to find the biggest perfect square. You keep trying, okay? So you can start high. I mean, 64 is too big. 49 is more than half. So 36 doesn't work. 25 doesn't work. 16 doesn't, or sorry, 36 does work. I was on another number. 49 is too big. 36 does work. 25 doesn't work. 16, I don't care about anything else. If 36 works and that's the biggest, that's what I'm using. Now, if you tried to use the number 9, because that's my first thought. When I was looking at 72, I think 9 times 8. Guys, 9's a perfect square. So if you have this answer, you're not fully wrong, but you didn't simplify it because 8 can break down. Doesn't 8 divide by 4? So another way I know I didn't get the biggest perfect square is that there's a perfect square hidden in this factor. And that 9 times 4 gives me my 36. All right, so this would be 6 square root of 2. And that's why I like to put the perfect square first so I don't flip-flop things. All right, look at 96. I'm going to give you a second. My suggestion is you start high. 100's too big, 81's too big, even 64's too big. Does 49 work? Does 36? You're literally taking your calculator, because I always get a kid a week later that says, I don't know how to do this. Take 96 and divide it by 49. No, it doesn't give me an even integer. Take 96 and divide it by 36. Nope. 96 is not going to divide by 25. How about 96 and 16? Okay, then I'm done. Now, 96 will also divide by 4, won't it? But if you try to use that 4, you're missing that 16 goes into it. And see how 24 is left over? 24 has a perfect square of 4 in it. So we didn't find the biggest perfect square if there's another one tucked in here. So we're going to break it up to what? 16 times 6. So do you see that it just takes a little bit of trial on your calculator? I'm not asking you to know it all. I'm asking you to try for it. All right, this would be 4 times the square root of 6. So this is understood that it's multiplying. All right, let's go back over to this side. Square root of 104. Why don't you guys try number 7 and number 8? You got your list of perfect squares, and then we'll come back and work on it. All right, ladies and gentlemen, 104. What did you find as a perfect square that went into 104? 4. Now, you would have probably, I mean, starting up at 100 is unnecessary because if you're dividing, you want to even factor, dividing by 2 would give you 52. So you can always take a number, divide it by 2, and that's your cutoff. You would test all the numbers below that, but the only number that works is 4. 4 times what? 26? Okay, now, seems like 26 is a pretty big number compared to what we've been having left under the square roots. So you have 2 ways of knowing that 4 was the best. 1, you literally tried everything up to halfway of that number. Nothing else worked, you didn't skip anything. 2, what are the factors of 26? Are there any factors that are on my list? And my only factors are 2 and 13, and those aren't perfect squares. So that's how you know you found the biggest perfect square. So you should have the answer of 2 square root of 26. Now, just a reminder, this 104 we looked at as 4 times 26, and I can always do that. 4 times 26 is 104. It's underneath the square root, and that's why we're allowed to break them out. All right, 289 wasn't on your list, was it?
No.
All right, did you try it first, since it was a bigger number? The first, because I know it wasn't on your list. Now, you could add these numbers to your list. I mean, I have them up here. You could add these numbers to your list. But if I am unsure and it's bigger than my list, the first thing I'm going to do is take the square root of 289. The first thing I'm going to do is take the square root of 289 and see if it's a perfect square, and it was. It's just 17. I don't have to do anything. If it wasn't 17, then I would try to break it down. Okay, so did anyone try the next ones, or you were just on those 2?
No, I did all of them.
You did all of them?
Yeah.
All right, well, I'm going to give you guys a minute to try the next 2 and make sure you get the biggest perfect square, and then we will check those. 192, what did you find that went into it as a perfect square?
16. Yeah.
Ah, 16 works, but it's not your best option. 192. 16 times what? What was it? 16 times what?
12.
Ah, okay. So there's 2 ways to know that 16 wasn't your biggest perfect square. 16 is a perfect square, it's on the list. 12, does it have any perfect square factors, meaning numbers that divide into it? 4 goes into 12, doesn't it? Ah, so if you look at 12 and you see that 4 and 3, that perfect square times the perfect square that was hidden in the 12, 16 times 4 is 64. If you multiply 2 perfect squares together that came from that number, you'll get the biggest perfect square that goes into it. So it's actually 64 times 3. Now, you're right. 4 goes into it, so does 16, but you have to exhaust your list. Does 25, does 36, does 49. Half of 192 is just under 100, so you should have tried up to 81, okay? So if we're looking for the biggest perfect square, I think the quick way to do it is to take 192 and estimate it. If I divide that by 2, it's just under 100. So then my 100's too big, and I would start with everything underneath it. All right, so what is the square root of 64? 8, and I keep that square root of 3. Now, if you would have done it with your 16 and 12, again, you're not wrong, but you're not going to get full credit. You would have 4 square root of 12. Now, 4 square root of 12, that is the same decimal that we would get from the square root of 192. It's the same decimal we get from 8 square root of 3. But the reason it's not going to get you full credit is not simplified enough, so you'd have to break the 12 down again, and I like to just do it once. All right, square root of 500. That's not even on my list. So the first thing I'm going to try is put it in my calculator. Is the square root of 500? Oh, let me try that again. Square root of 500. Nope, not a perfect square. We can agree? All right, well, half of 500 is 250. So 289 is too big. 256 won't work. Does 225 work? No. All right. 196, no, no, no. 25 works, but so does what? Ah, so square root of 100 times the square root of 5. Isn't 5 times 100, 500? I got the biggest perfect square because we tested them. I got the biggest perfect square because 5 doesn't break down with the perfect square. What's the square root of 100? So it's 10 square root of 5. All right. Numbers 11 and 12. I'm going to pause this and give you a minute to try those. Now these numbers are a little bit bigger, so you're going to have to fight with them a little bit. So we were talking about taking half of this, which would be close to 200. So I don't need to try 225, but I would start with 196. And 196 did divide into this evenly twice. So I would have this as the square root of 196 times the square root of 2. And this is understood that it's multiplication. And that would be 16, or no, not 16. What is it? 14 square root of 2. Yep. Caught myself. 14 square root 2. I hope you're seeing the point of why I asked you to write down your list of perfect squares. I'm not worried about what divides into 392 unless it's a perfect square. That's all I'm interested in, okay? Now look at your 405. Half that would be around 200. So 225 does not go in. 196 does not go in. You're literally taking your calculator, yes, and taking 405 and dividing it by this list. Did you find something that went into 405?
81.
81. Now, what also goes into 405 was 9. Who would have known that? But 9 goes into 405, but see, 81's bigger, isn't it? And the reason I know 9 goes into it, because 9 goes into 81. Okay, so we would then take this and make it the square root of 81 times the square root of what? 5? That's all you had to do. This is a matter of sort of patience. Take your number, start dividing by these. I'm literally taking my calculator and dividing by 169, divide by 144, divide by 121. It took some time, but we got 81. And once I get my biggest perfect square, I don't have to keep going down the list. Now, if you're starting here, you have to go at least till you hit halfway to make sure you've exhausted your possibilities. This would be 9 square root of 5. That's it. So your goal is to find the biggest perfect square, and that's why this sheet will help guide us. It helps us focus to look to see what of these numbers work.